Hey guys, welcome to Chapter 11. Chapter 11 is all about volume. Alright, in Chapter 10, everything was two-dimensional and we were able to calculate area of two-dimensional shapes. Now we're moving on to three-dimensional figures, and we want to be able to count or calculate the volume of those three-dimensional shapes. So today's lesson is going to be quite a bit of note-taking and being able to recognize different aspects of three-dimensional shapes that are pretty important for moving forward and actually being able to go through those calculations. Alright, so let's get started. Solids. Three-dimensional figures, or solids, can be made up of flat or curved surfaces. Each flat surface is called a face. An edge is the segment that is the intersection of two faces. And lastly, a vertex is the point that is the intersection of three or more edges. Alright, now all of that can pretty much be seen at the picture to the right. Alright, we have these flat surfaces that we shaded called a face. We have an edge right here that's connecting this right face and the back face right here. And then lastly, here's an example of a vertex where what happens? Well, there's one edge, two edges, three edges meeting at one point called the vertex. Now that we have some of that done, let's get into some more specific situations and what type of three-dimensional figures we might have. Alright, so first let's focus on prisms. Prisms are formed by two parallel, congruent polygonal faces called bases, connected by faces that are parallelograms. Prisms are named for the shape of their bases. We'll get a little bit more into this later, but being able to recognize these bases is super, super, super important. This idea that they're formed by two parallel, congruent polygonal faces is something that might be difficult for some of you to visualize. So we'll go through some examples later, but right off the bat, if we take a look at this picture to the right, hopefully you guys can notice that here in my picture are two triangles that are not only congruent, right? We have the exact same triangle both on the bottom and the top, but they're also parallel to each other. They're not touching. Okay? So again, we'll see some more examples later, but this idea of parallel and congruent faces is really important. That's a concept that you're going to have to work to master. Moving on from prisms, we have cylinders. Cylinders are formed by two parallel congruent circular bases and a curved surface that connects the bases. Bases. This is a little more straightforward, and you probably have heard of cylinders before. Alright, the idea that these bases are circular, it's pretty easy to recognize a cylinder because there are two parallel congruent circles for bases. Moving on, our next shape or our next type of solid that we're going to focus on is a pyramid or pyramids. And pyramids are formed by polygonal bases, formed by a polygonal base and triangular faces that meet at a common vertex. Notice I corrected myself. It's really, really important to recognize in a pyramid there is only one base. That is a concept that kind of distinguishes between a pyramid and a prism. Notice above, in a prism, if we slide up for a second, prisms are always going to have two congruent bases. And then in pyramids, we notice that there's only going to be one base. Lastly, pyramids are named for the shape of their bases. Again, it's very, very similar to prisms. All right, moving right along. The next figure that we're going to focus on are cones. Cones are formed by a circular base. Once again, that was a singular base, right? There is only one base. So cones are formed by a circular base and a curved surface that connects the base to a vertex. I would say cones are pretty straightforward. I mean, we have ice cream cones. A lot of you guys have probably seen cones before, so they're probably a little bit easier to recognize. The last shape that we're really going to focus on is a cube. All right, a cube is really just a very specific prism. All right, so a cube is a prism with 6 square faces. Hopefully you guys can see that. If you notice, all of these edges are all congruent. I could make tick marks on every single one of these sides, and what do we notice? Well, if all of those edges are the same, then all of these different faces are perfect squares and identical squares. So that's what makes a cube a cube. In general, when we're naming prisms and pyramids, they're always going to be named for the shape of their base or bases. All right, so here we go. Let's go through some examples. When we look at these pictures, we need to remember some of our definitions that we learned on the page before. All right, we know that prisms have to be formed by two parallel, congruent, polygonal faces. So when I look at this first picture, I can maybe look at this left face right here, but then I ask myself, is there another face kind of across from it or somewhere else in this polygon that's both parallel and congruent to this? No, there isn't. I could say the same thing with more of this front face. The front face does not have a match or a pair that is both that is both parallel and congruent to it. What I would hope that we can see after looking at this for a little bit is that the bottom is a triangle and the top is a triangle. Those two triangles are both congruent and parallel, which means those triangles are the bases. Now that we've established that it's a triangle that is the base, we can name this. All right? How do we name again? Well, we use the base to name. So, because the base is a triangle, we are going to call this a triangular. And then the next word is really just going to be what shape it was. Is this a prism or a pyramid? Well, hopefully we notice that because there are two bases, this is a prism. All right? Moving on to the next picture. Here we have some options. All right? If we notice, I can kind of find multiple sets or multiple pairs of parallel congruent faces that I can call bases. You could use the left and the right, or you could use the bottom and the top. You could even use the front and the back. In this case, it doesn't really matter which set you use, just that there is a set. For that, just because I a lot of the times like using bottom and top, I'm going to go ahead and outline the bottom base and the top base, which are both, hopefully we can see down at the bottom that there's right angle markings at each vertex. So we can call the base a rectangle. Now remember, we're not going to call it a rectangle prism, we're going to call it a rectangular prism. Why was it a prism again? Two bases. If we move on to the next picture to the right, all right, I'll ask myself, do I see any parallel congruent faces? Well, looking at these sides that are kind of going up and down, I'm not really seeing something that's parallel and congruent to this face, or even like this side, or even the back. What I'm looking at is the bottom. Alright, that bottom has a match, and it's on the top. Those two faces are both parallel because they're not touching, and they're the exact same shape, so they are congruent. That means that those are our bases. Now to name it, again, we use the shape of the base. The base is a pentagon, so this is a pentagonal prism. Easy enough, right? Our last prism is this one right here. This is probably the toughest one, and I would say that it's tough because I might be able to see a couple of different sets of congruent parallel faces. The other thing that we have to remember is that the bases, whatever we determine to be the bases, they always have to be connected by parallelogram faces. For example, if I look at this kind of front left side and then kind of this back right side, I might say that those are congruent, even though they don't look super congruent. They could be congruent and parallel, but what's true? Are they connected by a single face? No. There are actually two different faces that connect those two faces. So for that reason, those cannot be our bases. So we have to re-examine and we have to look for two bases that are both parallel and congruent. Hopefully we're kind of getting the hang of this, and we can see that we have, again, bottom and top shapes that are congruent and parallel. So now that we have that, we already knew that this was a prism because there's two bases. We just have to name it using the shape of the base. Well, both of the bases are hexagons, so this is a hexagonal prism. Awesome. Moving on, I want you guys to try and just take a look. Notice that all of these lateral faces and all of these pictures, all of them are triangles. That's a key way of determining that a solid or a figure is a pyramid. Because all of these are made up of triangles, we know that our name, all of them are going to be pyramids. So really all we have to do is we have to figure out and maybe sketch in or highlight the base, and we're going to be on our way. So in our first picture, once again, along the bottom, I'm seeing this triangle. So this is a triangular pyramid. When I move to the next picture, there's only one shape, in this case it's going to be the base, that isn't a triangle. Hopefully you guys see along the bottom is a rectangle, and I know that because of the 4 right angles. So here we have a rectangular pyramid. If I keep going, once again, there is only one face that is not a triangle. And again, it's the bottom. So that's going to be our base. It just so happens to be a pentagon, 5 sides, so a pentagon, which makes this a pentagonal prism. Sorry, pentagonal pyramid, my bad. You guys can probably figure out the last one after going through all of these examples. Once again, there is only one face that is not a triangle. It's the bottom. It is 6-sided. Sorry, that was bad highlighting. 6-sided, meaning that the base is a hexagon, which makes this a hexagonal pyramid. Just to close, I know that this might have been slightly boring. We didn't do a lot of work yet. We will get there, don't worry. I really want you guys to know that being able to recognize the bases is super important. Otherwise, we're not going to be able to carry through and go on with our formulas that we're going to learn for calculating volume. So, do what you got to do. Let's work on this. Let's ask questions. And let's make sure that we have a good grasp on this first section of Chapter 11. See you guys later. Peace.